Welcome back, and we continue talking about safety in the cars for now, and we'll close with some graphs of motion. Let's have a look at this one quickly. I said airbags will increase the time of contact, okay, between you and the airbag, and in that way lessening the force that actually causes the damage on you during accidents. And that it does, according to this, we know that the force equals change in momentum over change in time. You make that factor there bigger, you're saving life. And that is how, that's actually the law of physics from which airbags operate or saves people's life. In a crash test, a car of mass 1.2 by 10 to the power 3, that should be 10 to the power 3 kilograms, collides with a wall and rebounds as illustrated below. The initial and final velocities of the car, 12 meters to the left and 2 meters to the right, respectively. The collision lasts for 0.1 second, okay? And that is the diagram for that problem there, as we have just read it. Calculate A, the impulse of the car during the accident. Now, impulse equals change in momentum. Now, let's say, because momentum is a vector quantity, let's take direction now. Let's check our directions and choose. Let's take to the right, direction to the right to be negative. I'm just choosing it to be negative. You can choose it to be positive. Therefore, this impulse equals change in momentum should be equal to m into v final minus v initial. The mass of the car is 1.2 by 10 to the power 3. Final velocity is to the right, and to the right is negative, so I'll call it -2. Minus. Initial velocity is to the left, which is 12. I will have it as minus, as positive 12 there, but there is that minus there. This minus is the one from the formula. Now this works out to be minus 1,68 by 10 to the power, okay, by 10 to the power 4 Newton seconds. Now I want you to be careful here. You're calculating for impulse. The unit of measurement for impulse is Newton seconds. Don't put in the kilograms meters per second, okay? That is momentum, and it ends there. Why do we say Newton seconds? Is from the fact that this is from here. Impulse is F times delta T, which is of course change in momentum. So Newton for force and seconds for time. So that's where that unit comes from. Okay, and then moving on, you are asked to calculate the average force exerted on the car. Average force exerted on the car, you need to take it from impulse given by change in momentum. We have already calculated for change in momentum. So the force times the time of contact between the car and the wall was 0.1 seconds. It's given to us. So delta T is 0.1, should be equal to the change in momentum that we have calculated for, and that we found to be 1,68. Okay, you can put in the negative because we found it to be 1,68 times 10 to the power 4 Newton seconds. Remember, you don't have to put in units there. So F should be equal to minus 1,68 by 10 to the power 4 divided by 0.1. And that should give us 1,68 by 10 to the power 5 newtons. So that is the force that the wall is exerting on the car, or the car is exerting on the wall. Remember, this is Newton's third law. For every action, there's a reaction. That is not a good one. You say if object A exerts a force on object B, object B will exert exactly the same amount of force on object A, but in the opposite direction. Okay, so it's action-reaction pairs that we're talking about here. Now let's look at something here around graphs of motion. A boy stands at the edge of a high cliff. He throws a stone vertically upwards with an initial velocity of 10 meters per second. The stone strikes the ground at a point below the cliff after 3.5 seconds. The velocity time graph below was obtained from the measurements made during the motion. So there is the graph. Okay. Now let's have a look at the question itself. Okay. The question itself. Let's look at it. Calculate the acceleration of the stone between times 2 seconds and 3 seconds. Now you go back to the graph. Between times, is it 1 second or 2 seconds and 3 seconds? Okay, 2 seconds and 3 seconds. So we want to know the gradient between that time. So it is this point there that is going to help us and that point. If we find the change in y and the change in x there, we will find the answer. Okay, how do we do that? This is velocity in meters per second. This is time in seconds. So here, the gradient, the acceleration A will be equal to gradient equal to change in v over change in t. Okay, so change in v will be what? Look at this. This will be minus 20 minus 10, because v is 10 there, minus 10 minus 20 there, divided by the time, 3 minus 2. Okay, 3 minus 2, that and that. So there you have got minus 20 plus 10 is minus 10, divided by 3 minus 2 is 1. So you've got minus 10. This is meters per square second, because you dividing meters per second by seconds. So you get the acceleration. That means a gradient from a line graph, a velocity time graph, gives you the acceleration. Thank you so much for watching. That brings us to the end of the lesson. See you next time. Bye-bye.